Hey y'all, welcome to another episode of Visual Studio Toolbox. I'm your host, Leslie Richardson, and I'm joined once again by Matteo Prosperi from the Extensibility team in Visual Studio. How you doing, Matteo?
I'm doing great. Thanks for having me, Lesson.
Thanks for being here yet again. I say yet again because if you're watching this, you are knee deep in a playlist that's been going on for the past year, all about how you can get started with extending Visual Studio using the brand new extensibility model. So if you're coming into this playlist for the first time and this is the video you clicked on, highly recommend going back to episode 1 and starting from there. The link to the playlist is below. That said, if you have been watching the playlists and you're jumping around for whatever reason, I'd also suggest not starting here. This is like part 3 of like a sub conversation we've been having within the playlist about what happens when you need to involve in-proc components alongside your mostly out of proc extension, or for whatever reason you just want to go in proc. So go back like 2 episodes ago where we kind of kickstarted that conversation at the very least, because we're not going to recap those in full. But, if you're here for real, welcome, and we are continuing our conversation about basically how to attach those different in-proc components, and specifically, we're gonna be talking about MEF components, which might be a familiar thing if you're familiar with the old, extensibility model, among, async packages and more. So, Mateo, just to kick things off, why would people need to do this?
Well, I'm actually not going to give a use case this time.
Okay.
Async packages and MEF components are going to be very, very familiar to anybody who has written VS SDK extensions, so our traditional extensions for Visual Studio. Probably they're going to feel like API archaeology for someone who comes in fresh using the new Visual Studio Extensibility APIs. So I'm not going to tell people, this is when you should use this. The idea is that, well, you will use this when you really need to. And people who know, they know when. I will explain what an async package and a MEF component are so that it is clear for everybody. But the idea is that if you're using Visual Studio Extensibility, you should go and use an async package or a MEF component when you really have no other way around to do things. Otherwise, stick to the new APIs. They're going to be more modern, easier to use, way harder to get them wrong.
So, this is really a case of you'll know it when you see it.
Exactly.
And
If you know that you want to do this, this episode is about how you go and do it.
well, let's check out what that situation looks like then.
Absolutely. So we're going to talk about a Visual Studio extension. This guy, it's called AsyncPackage and Math. And this is one of our samples on our samples repo on GitHub. So you can go and find all the source code. You can F5 debug it. You can test it out, and it comes with a README that actually explains all of this in probably even deeper details than what I'm going to do today.
We're
There's
also gonna link that in the description too, so
That's great. What are we going to look at? So we know that we want to write a Visual Studio Extensibility extension. This is going to be an in-proc Visual Studio Extensibility extension because we want to mix and match VSSDK concepts and the Visual Studio Extensibility concepts all together. We have seen some of this in the last 2 episodes. So 2 episodes ago, it was how to build an in-proc extension and use VSSDK APIs. And last episode was about how to write an extension that has some in-process components and some out-of-process components. So those are going to be very relevant information for what we're going to do today. Today, we're going one step further in the interoperability and look at math components. Those are the traditional dependency injection framework that is used in Visual Studio, and async packages. Async packages are basically your VSSDK extension entry point. It is used to provide functionalities like tool windows, like command and menus and stuff. Both of those, both tool windows and commands, they have a more modern Visual Studio Extensibility APIs that you should really consider using instead. But if you end up in a situation where you have to use a component as part of your extension, or you need an async package, and well, you're going to know why that's the case for you. There are some very specific things to be careful about to make the interaction being safe and reliable, and that's what we're going to talk about today. I'd say the first thing to be careful about is that the MEF component, async packages, and the extension, the Visual Studio Extensibility extension, they are all initialized independently. So all these components are lazy loaded, so they are only loaded when they are needed, and they are all initialized independently. So the biggest problem that we're going to have to solve is if one side of this galaxy of
Hi.
components has to have any other, well, they cannot just expect that thing to be there. It may not be initialized yet. So that's going to be the big part of how are we going to do this safely. Okay, so let's have a look at some of the parts of this extension. So we can start from the CS project file. This is going to be very similar to what we've seen before. So it's an in-process extension. So it has a target framework net472 because it's going to load inside the event process. And it is marked as such as a VSSDK compatible extension. And as we've seen, in this case, we include both the new APIs, the Visual Studio Extensibility, the traditional APIs, the Visual Studio SDK, and the build tools that allows us to create a V6. In addition to that, we are generating a package dev file, which is basically a list of stuff that our extension contains, and that will tell Visual Studio that they can, Visual Studio can find these things in the extension. This is going to be things that are provided, traditional VSSDK components that are provided by the extension. We're going to see all of that. And we're going also to say that we're using code bases. So that's when it comes to the CS project file. The other part is the V6 manifest.
Mhm.
So again, very similar to what we have seen the other times. This is an in-process extension, so all the metadata is defined here. And this is as extension type VSSDK plus Visual Studio Extensibility. This is, again, basically the same thing as saying that it's an in-process extension. And we have these two special entries where we have a MEF component, which points to the current assembly, the current DLL, and a VS package, which points to the package def of this extension. So all of these things, they need to be there for Visual Studio to find, discover your MEF component that we are going to see soon how we create one of those, and the async package. And also we're going to see soon how we're going to create one of those. That's all the setup that we need. And from here, let's actually start and do some interaction. So the first thing that we're going to try is, let's say that we have a MEF component. We want to create a MEF component, and we want our Visual Studio Extensibility code to interact with the MEF component. This is only going to be possible from in-process because MEF is only for in-process extension. So what we're going to do is we're going to create a MEF component. So this is it. This source code is divided in two folders. We have the VSSDK, so this is the traditional stuff, and the Visual Studio Extensibility folder. This is the new Visual Studio Extensibility stuff with everything modern. And we're going to see how we can talk between these two.
So, what does MEF actually stand for? I think it's basically like dependency injection,
Exactly.
extensibility edition, but
It's one of those cases I've always used the acronym. I don't think I've ever wondered what the acronym actually means.
yeah, no, I'm curious.
But it is a dependency injection framework, and it was not born directly in VS, but it is used extensively in VS.
Managed extensibility framework. That's
Okay,
what it
that's
stands for.
neat. Yeah, I learned something.
It's a little more generic than I expected it to be named as, but
Yeah, it's very much not an exclusively Visual Studio component. A Visual Studio concept it's can be used in other applications as well, but it is used as the dependency injection framework in process VS in VS SDK. While in Visual Studio Extensibility extension, we use the more modern .NET dependency injection, the one that's generally used for like web applications, for example. This is a MEF component, so it can be basically anything. It's going to be a class that we define and that we export. So we're just saying, oh, this thing is going to be available for others to import. And it is, in this case, exported as its own type. So very simple. It's this MEF is really, really flexible. We're not going to do any complex scenario here. We just want to see how this thing can be consumed. This component is going to have a say hello method that shows a user prompt. It's a pop-up dialog that says hello from a MEF component. So these are very much proof of concept samples. They're meant to be as simple as possible to show people how to use these APIs. So first of all, let's see how we go and use this. So in order to use this, we have an interact with MEF component command in the Visual Studio Extensibility portion of the extension. So still in proc, but written with the new APIs. And we have seen how to do this 2 videos ago. When we were looking at the comment remover, if we want to use a MEF component inside a command or another class that is dependency injected, we just use a MEF injection, the MEF injection type. So in this case, we want a MEF injection of my MEF component. My MEF component is the type of the object and the type that the object is being exported as. This is going to be the new .NET, modern .NET dependency injection framework, but this is saying you need to go and reach into the traditional MEF dependency injection framework and get me this thing. We're getting it in the constructor, and then when we use it, we just need to actually get the object through an async call. And once we have the object, we can call methods on it. So in this case, say hello async. If we want the MEF component to have access to the Visual Studio Extensibility APIs, we know that the Visual Studio Extensibility APIs are generally accessible through the extensibility object. The traditional VS SDK part of the extension doesn't have access to the extensibility object. If we want to use that from there, we need to pass it as a parameter, and that's what we're doing. So we're going to say, we're going to pass you the entry point for all the Visual Studio Extensibility functionalities, and you can use it. And once we have it, we can do things like, for example, calling a show prompt command. So
gotcha. So I guess on the topic of initialization, once these components reach like aware of each other's existence, how do you know as the developer like the order of how they're being initialized? Like if you needed to debug this later, is there an easy way to kind of determine what
so
is
the,
initialized first?
so both MEF, async packages, and the Visual Studio Extensibility extension entry point, so this type, and all contributed the Visual Studio Extensibility parts, for example, a command, they're all lazy loaded. So they are loaded when there's somebody else needs them. So in this case, what we're going to see, if we had to debug this and start putting breakpoints, the order of, first of all, nothing would happen in here. No breakpoint would be it until we go and we call the command. So somebody clicks on this first command from the extensions menu. When they do, first the extension entry point is initialized because that's guaranteed to be initialized before any Visual Studio Extensibility component is initialized. Next, the command is initialized because that's what's being used. When the command tries to retrieve the MEF object, the MEF object is going to be initialized. So at that point, within this call, we would see that the constructor for the MEF component would be it. And from there on, everything is initialized. Interestingly enough, the async package that's also in this extension, we haven't seen it yet, is not going to be initialized at all because no part of this chain needed the async package. That's what happens, and that's why you can't do things like just do something like, for example, static MEF component instance. You couldn't do something like this or something like that, and just to say, well, we are actually in the same assembly. We're both in proc. We can just reach out for that static instance. No, all that stuff is not going to work because all of this is not initialized yet. So in order to interact with the MEF component, we need to make sure that the MEF component is initialized, and we do that by injecting the MEF component through the MEF injection inside the Visual Studio Extensibility part that wants to use it, and then we can interact, and that's what we do on this line. If the interaction starts the other way around, we're going to see later how a MEF component or an async package or some other stuff that is VS SDK stuff can reach out and get a part of the Visual Studio Extensibility extensions to interact with. So we're going to see all part of this interaction. If we want to see how this works, this is kind of a boring demo, but we have the command that we create, interact with the MEF component. This is going to create the initialize the extension, initialize the command, get the MEF component, and call the method which shows this pop-up dialog. This is kind of a lot, but we're going to see more. So the next thing that we can have in this interaction between Visual Studio Extensibility and the VSSDK component is a sync package. There is some more code than this in the sample online. I commented it for now because we only care about these few lines of code, and I will uncomment it later. Now we have this other thing that is an async package. Again, a sync package is the heart of a VS SDK extension. An in-proc Visual Studio Extensibility extension does not need to have an async package. But if you need it for some reason, this is how you create one. You extend the async package, and then you have this couple of registration attributes that you need to add there. Our async package, I'm sure, is going to be doing stuff that's not included in this sample. The question that we try to solve here is if my Visual Studio Extensibility extension needs to reach out to the async package, make sure the async package is initialized, and actually talk to it. How do we do it? That's how we do it. We expose a VS service. So this is not a brokered service. This is a traditional Visual Studio service that you generally retrieve in Visual Studio through the async service provider. So what we're doing here inside the initialize async method for the package, we add a service. This is going to be this type that's called my service. The creation of it is going to be created on demand when somebody tries to retrieve it, and we just call the constructor to create one. We also need to declare through an attribute that this package is going to provide the service, so the Visual Studio knows that when somebody requests this service, this is the package that needs to be initialized for the service to be available. Now that we have set up this get service call, we can actually see what the service look like. And very similar to the MEF component, there are no strict rules. The service is just a class. And in this case, the class is also exposing methods. Very similar to what we're doing with MEF, we wanted to show a user prompt. Prompt will say hello from a VS service, and same rules apply. We cannot retrieve the extensibility object if we wanted to interact with the modern Visual Studio Extensibility APIs. So in order to be able to call the show prompt async from the new APIs, we need to have the Visual Studio Extensibility part of the extension to pass that Visual Studio Extensibility object to us. As you can see, this is very, very simple, and we can see how we interact with it from the Visual Studio Extensibility command. So we have another command, very similar, also placed in the extension menu. And this time we do dependency injection of an async service provider injection. So before we used a MEF injection to retrieve a MEF service. This time we use an async service provider injection to retrieve a VS service. Again, we have seen both of these in the comment remover video 2 videos ago. In that occasion, we were retrieving MEF components and services that are already provided as part of Visual Studio. In this case, we are retrieving our own that we are defining as part of the extension itself. We get this injection object, same thing as before. We need to get the actual service when we want it. Then we can call the say hello async method. And same as before, we can play back the whole initialization sequence for people who are interested. What would happen? Again, everything is lazy loaded, so nothing would be initialized by default until the user interacts. When the user interacts, the first thing that they do, they interact with the command. So the extension entry point is the first thing that it's initialized. Then we would have the execute command async method being called. The execute command async method gets to the get service async call. The get service async call now is asking for the VS service, but the VS service is provided by the async package. So the next thing is the async package is going to be initialized. Once the async package is initialized, now VS knows how to get the service and it will initialize the service. After that, we have the service, we can call the say hello method on it. So this is the whole chain. If we look at the generated extension for this, obviously it's a V6 file. If we go and open it and look inside the V6 file, as we said before, there's the V6 manifest. So we have edited that, we have written that. So again, this one tells us that there is the async package and MEF package stuff. So that's how Visual Studio is going to find the async package by looking at the package def file, which we are going to look at in a second. And the MEF component is inside the DLL. So the package def, this is generated based on these attributes because we asked to generate the package def file here in the CS project. The package def is not a file that we write, it's a file that it is generated for us, and it contains these entries that tell Visual Studio what are other stuff that are provided by the extension. So in this case, the extension contains the async package, which is there. It's going to say in which DLL that's provided, what's the name of the class, and so on. And it's going to contain the my service, so the VS service that the AsyncPackage is providing. So that's also listed there. So if you ever are debugging something's not loading, maybe have a look, make sure that these entries are there, but they are supposed to be generated for you. This covers everything about how Visual Studio Extensibility extension can reach out and get an async package or a MEF component, so traditional VS SDK components, and interact with those. But that's only half of the problem. Sometimes your extension works the other way around. Sometimes your extension has a MEF component or a stuff that is initialized by an async package, and those need to go and talk to the components that are in your Visual Studio Extensibility extension. These may be in-proc components, which is what we're going to see today, but they may be out-of-proc component as well. So both are valid designs depending on your needs. Generally, if you have some modern .NET, like .NET 8 dependencies in your extension, you may have to have an out-of-proc part of it. And that's something that we have discussed in the last video. So how do we go at having this traditional VS SDK parts of the extension that are here in this folder, go and talk to the other stuff that is in the other part? We're going to do the same thing that we've done in the last video. So we're going to have the Visual Studio Extensibility part of the extension expose a brokered service that can be interacted with. So what we're going to do is we're going to have the my brokered service. And we have seen all of this last time, but I will recap it quickly. It implements an interface. It is a Visual Studio contribution, and it has a configuration. The configuration contains a name and a version. That is how the broker service is uniquely identified, so that's how it is retrieved. And after that, it just have methods. Like in this case, we have two methods, one start report in progress async and one stop report in progress async. And the idea is that this brokered service is going to give access to Visual Studio Extensibility APIs for the traditional VSSDK part of the extension. And so in this case, they just wrap two calls to the progress reporting APIs. So this is the service. So again, very simple, just two methods. Now that we have this set up, we need to do a couple things more. So one thing is going to go and declare somewhere that this broker service is provided by this extension. So this is a part that is slightly weird because the broker service is part of the Visual Studio Extensibility section of the extension. But we are going to put this attribute on the async package. The reason we are doing this is that we want this service to be listed in the package def, because this will provide the best reliability for your extension. So even the Visual Studio will know that this extension is providing this service from the very start, even before the Visual Studio Extensibility extensions are even looked at and discovered. So most of these extensions would still work even without this, but for the best reliability, we want it there. And we could write this thing by hand if we really wanted to, but it is easier to have an async package and have this attribute there so that the package def generation will take care of adding that entry for us there. So that's the
So if
first
you
thing.
didn't have that attribute, then you'd have to do all that manually.
If you didn't have that attribute, you can create just a file named package def and put it in the V6 and it would still work. That's a viable option. Or if you didn't have this entry at all, Visual Studio would get to know that these components exist when the Visual Studio Extensibility extension is looked at. So that is why we didn't do this for the brokered service that we created in the last video, because those were only used from the Visual Studio Extensibility part of the extension. So by the time any of those services could be requested, the extension by default would be instantiated. And so that means that Visual Studio for sure knows what the extension contains. But in this case, we may look at these files. We may need this service. We may need this service from a VSSDK part of the extension, which this is not the case, but in some cases it is loaded very, very early in the Visual Studio startup process. So we want to make sure the Visual Studio knows from the very start that this service exists and it is provided here. So we want it to be in the package def as well. So the other things we do is we're going to write some code in this code can be invoked from anywhere. For example, a traditional VST command may want to request the brokered service because it wants to reach out and interact with some Visual Studio Extensibility APIs, for example. So we want some new feature, but we still have a VST command. Or it can be any other Visual Studio SDK component that we have that may want to do this. So it doesn't really matter when we're going to call this method, but if we want to call this method from the VS SDK part of the extension and we want to reach out to the Visual Studio Extensibility part of the extension because we want to use some of those APIs, we are going to go and get the service broker container. In this case, this is how we do it from an async package. There are different ways of doing it depending on where you are in the Visual Studio SDK extension. These are kind of advanced topics. So if you're doing something like this, you're probably familiar with the VS SDK extension, so you know all the ways you can get a service broker container. Once you have it, you can get the service broker, and when you have it, you can request a proxy of your brokered service. So this is the actual broker service that I have defined here. this guy. So now we have the proxy, and we can do the calls to the proxy. So in this case, we do a call to start reporting, doing some work. Then we wait 10 seconds, and after 10 seconds, we say, well, the work has completed. So there are a couple of interesting things. It would seem easier to, instead of creating this service, just to create a service that returns the extensibility object. So I could do my broker service proxy dot get extensibility, and inside of here, inside of the broker service, where I have access to extensibility, I would just do return extensibility. Well, we're not doing that because this would not work. And this is the issue. MEF services and traditional VS services, like my service down here, those are meant to be used exclusively in process. So when you retrieve one of these objects, either the MEF components or the service, you are getting the actual real object. And so you can pass instances of objects, you can retrieve instances of objects. These are all local calls into normal C# classes. When you're getting a brokered service are meant to work across different processes as well. So when you get the service, you see we are calling this proxy. We are not getting the actual object, we are getting the object proxy. And because we're getting the object proxy, everything that is passed in and out of this proxy is actually serialized. So we can pass strings, we can pass any type of objects that we have defined that is serializable according to how the service was defined. So in this case, the service is defined as using message pack as a formatter. So if the object is serializable with message pack, so it has the message pack attributes on it, then we will get a valid copy of that object. But not the actual original object, we get a copy of it. So in that case, we would not get the actual extensibility object, we would just get a failure saying the extensibility object cannot be serialized. So that's why we're doing it this way. And if we want to see it work, in this case, we don't have a good entry point. We don't have a VST command because I didn't really want to add samples about to provide VST commands to the Visual Studio Extensibility samples, since that's more of a legacy functionality at this point. So in this case, I just added the call inside initialize thing. So as soon as the package is initialized, it will start with this doing some work. So if we want to see it in practice, if we call the interact with AsyncPackage, we get the Visual Studio Extensibility command. The Visual Studio Extensibility command would get the async, the service from the package, and it should show the pop-up. And if you look down here for 10 seconds, we will also add this progress reporting happening because that happens as soon as the package is loaded. So if we wanted to actually see that, I need to start the experimental instance again because packages are only loaded once. So we go there. Now we will trigger the loading of the package, in this case by calling the command, and we see that we have the doing some work progress report that's going to be there for the next 10 seconds. And then it's done. And so these are all the ways that you can do interactions between Visual Studio Extensibility and all the traditional VS SDK components.
Nice. So yeah, this is definitely something that's a lot more of an advanced scenario. I think just judging by the steps that you have to consider and also the importance of initializing in the way that you want to initialize. Like you did it with like a handful of components, but I imagine like in people's very complicated extensions, there's a lot more components that have to be considered if you're needing to do this route, right?
Absolutely. But they should all fall into these three categories. So things that are part of the MEF dependency injection tree. So these are going to be things like our MEF component. This component could have import attributes, could have attributes in ported parameters in the constructor. So it is possible to get other MEF components to be part of the construction of this one component that we are defining. That is very, very common. If they're going to fall either in the MEF part of the extension or the async package and the things that depend on the async package, for example, traditional to Windows, traditional commands, or Visual Studio services, as we have seen here, or they're going to fall into the modern Visual Studio Extensibility stuff, like new modern commands, new modern tool windows, debugger visualizers, taggers, and so on. If you want to communicate from the Visual Studio Extensibility to the old stuff, you have those two MEF injection and async service provider injection. If you wanted to interact from the MEF part of the word or the async package part of the word with the Visual Studio Extensibility APIs, you create a brokered service there, and then you call into the brokered service.
Gotcha. Sweet. But yeah, it sounds like at the very least there are options depending on the scenario you're in.
Yeah. And again, if you have watched this video and it says, I have no idea what this means, don't worry. Probably you're just not meant to use it. But
No, when you see it.
if you were there and said, well, I don't understand how am I supposed to get all these things that I know what they are to work together, yeah, this video is going to answer the question.
Great. I think that's a pretty good summary. So that concludes, I think, our mini discussion about like those in-proc scenarios that sometimes need to be considered, whether it's because we're dealing with like legacy code or yeah, just things that are not yet supported by Visual Studio.Extensibility. So Matteo, thank you so much for joining us. I'm sure this won't be the last time I see you. There's still plenty more extensibility things to cover.
Thank you for having me.
Yeah, and thanks to everyone for watching. Once again, if you need a refresher or for whatever reason you felt like watching these really advanced topic episodes and now you want to go back to the beginning, there is a playlist link below. Also, if you want to follow along with this video, which might help because again, this is a very niche but advanced scenario, there is a sample that exists for under the Visual Studio Extensibility repo, and we have linked to that below. It also comes with a nice README on everything you need to know to both get started with that sample and also get a refresher on the things that we talked about today. Thanks again for watching. Join us next time for another episode of Extending Visual Studio. And until then, happy coding, y'all.